Hello, my fellow builders and home enthusiasts. You're welcome back to another exciting episode of the Housing and Construction channel, your go-to source for all things related to designing, building and maintaining your dream home. I am Bash, your host, and today we have a crucial topic to discuss, and that is why structures fail. Now with me here today is a highly experienced and a very resource person who is going to tell us more about the essence of why structures and engaging the right professionals for buildings is very necessary. You're welcome, Engineer Abel Cudjoe. Thank you for joining us.
Thanks for having me.
Yes, but before we dive right into our discussion, I just want to take some time to thank and acknowledge our sponsor. Yes, Ahimfie Estate is a leading real estate development company dedicated to providing top-notch and sustainable homes. We do appreciate your partnership. Thank you very much. So let's dive right into our discussion. So, structures have been failing in our country for some time now. Recently, we had news all over the country, some in Amamfrom, Adenta, etc., etc. So I want to know, what are some of the common causes of why structures fail?
Okay, so structural failure per se, structures in general may fail for a couple of reasons, okay? So let's say there are natural causes why structures or buildings will fail. Yeah. And then there are the non-natural causes. So the natural causes are probably maybe your building being in the crosshair of probably a natural phenomenon like earthquake, or flooding, or mudslide, or landslide, or maybe high wind, typhoon, hurricane. All these can cause a structure to fail. But these are natural occurrences. The non-natural occurrences are also the ones that are crucial because those ones are known, okay? And one has to design, in fact, when it comes into putting up a building, at the design stage, one has to design and then, make sure those things are worked out. So we also have the non-natural occurrences or the non-natural reasons why building also collapse.
Okay. So with these non-natural and the natural ones, is it a problem that can be detected at the very beginning before the building is built, or it is as the building is ongoing?
Okay, so for the natural ones, you can't. Okay, you can't predict when the next strong wind will pass or the earthquake is unpredictable. You can't predict that. The non-natural ones are ones that are predictable. So let's say, for example, take a building, for example. So you want to put up a building. There are processes that you have to go through. So probably the first, maybe I may group that into three main categories. Material. I may also group that into personnel, okay? Or maybe let me group that one rather into design and planning, which includes the personnel, okay? And then probably some few errors that will also be coming in. But let's take material. Material matters. It's very important. The kind of material you use for your construction. The kind of, all those inputs that you need, when you are choosing your reinforcement, when you are choosing your building materials, they matter a lot. But when you take, but the most important aspect is the personnel, for me, okay? Because let's say an ordinary person wants to put up a building.
Yes.
Most of the time, the first person they come into contact with is the architect, because the architect is able to put the client's thoughts into actionable models, okay? So the architect will design the spaces and make sure they are functional. They'll pick the client's brief and make sure they put the building down to, design it to suit what the client requires. But you see, there are a lot of personnel behind the architects. The architect doesn't do that alone, but there are teams behind the architect.
Like the structural engineer.
The structural engineer, in fact, among all the personnel behind the architect, there's only one professional who is responsible for the stability of the building, and that's the structural engineer or the civil engineer.
So where does the structural engineer come in after the design and all has been done to ensure the firm stability?
Okay, so now so the architects will now convert the client's brief into working drawings. Okay, how the building is going to function is none of the structural engineer's problem. The structural engineer's job is to make sure the building that the architect has designed stands. Do you get it? So, the structural engineer or the civil engineer will use structural systems to make sure the building is stable. Okay, if you talk about structural integrity, you just make sure that the building will stand the test of time and will be stable throughout its entire life cycle.
Structural integrity.
Yes, that's very important. That's very, very important. So now the architect will reach out to the structural engineer and then request for the structures of the building to be done. Now,
that's the structural drawings.
Yes, not just the structural drawings. Okay. But before the structural engineer starts doing anything, the building is modeled. Okay. The building will be modeled into a real life situation. Okay. In fact, now we have a lot of systems that engineers can use to model, let's say, the building, the structures of the building in its real form based on what the architect has designed. There are a lot of systems now or tools that you can use. So now, before the engineer goes in there to design the structures of the building, there are some information that will not be readily available to the engineer. So he will also request the services of other engineers. Let's say a geotechnical engineer, who will tell him how maybe the bearing capacity of the soil. So bearing capacity is actually the safe load per unit area which the ground can carry without any appreciable settlements. Okay, like the building that is going to be built on, like put on that land, you don't want the building to have appreciable settlements. So then the geotechnical engineer will tell the structural engineer or give the structural engineer an information as to how the ground below is structured. Then based on that, he will use the information there to design the foundation. So that is very important. Where you are positioning the building is very, very important. Because you see, when you take a swampy area, the foundation for that is different. Clay soil, the foundation is different. When you have made up grounds like swampy area, you filled with gravel and you've compacted, the foundation is different. Okay, when you have a normal gravel area, the foundation is there. So foundation is key. Okay. Foundation is very, very important, and these things, the civil engineers or the structural engineers are trained to get some of these things, like to design the right foundation for the right building. So not only the foundation, but every aspect of the building, is designed. The columns, the beams, the slabs, the staircases. These are structural elements that ought to be designed separately and then put together as a unit. Okay. When all these structural elements are functioning, the building will stand. You get it? But you see, along the line, a lot of things happen. Yeah. Now, so the structural engineer looks at the plan provided by the architect, models, analyzes, designs, and then gets the detailed working drawings for the architect. But that shouldn't be all. You see, that shouldn't be all. The moment you move from the moment the plan is given to the client and the construction starts, the structural engineer or the civil engineer ought to be on the ground making sure exactly. Okay. Most of the time, when the structural engineer produces the structural working drawings, he's taken out of the whole mix. The clients, in some instances, feel they can cut costs by getting some tradesmen, some masons, some steel benders somewhere to just interpret and go. But you see, sometimes even the actual information that are picked on the ground, it can change on the ground. Okay. And the structural engineer, for him to be actually liable for the building, he has to supervise his work and make sure what he has designed is actually what is being built.
So that also be a major problem because clients don't engage the right professionals.
Exactly.
They try to cut corners.
Exactly.
So do you know why? Is it because they try to run away from the fees? Are your fees too expensive? Can you help us understand?
Okay, so in fact, engaging a civil engineer is not too expensive. You see, the Ministry of Works and Housing has a standard approved fees. Yeah. That serves as a guide. Okay, on which a lot of engineers or professionals, even architects, they also go by that same fee structure. Okay, and they are actually moderate. But you see, the ordinary person trying to build always look for places to cut corners, and unfortunately, cutting the structural engineer out is what they see as a low-hanging fruit. But that is the most dangerous one. Do you get it? Yeah. Because you see, I can design a building, but the way the building is, I mean, put up. Even look, let me give you some. Let me give you some instances.
Yes, give me some. Give me some.
Okay, so a lot of people think when you put cement in more cement in concrete, your building is stronger.
It's going to be more stable.
Yes, or even when you use bigger iron rods, your building is stronger. It's not entirely entirely true.
So that's a misconception that is out there.
Exactly, because you see, you need to have the right reinforcement, quantity of reinforcement, strength of reinforcement in all this. Okay. So let me give you even one typical example. An engineer designs and says that, okay, so for this building, I'm using high tensile.
Okay.
The client gets to the ground or go to the retail shop to buy the reinforcement. Okay. Sees that maybe the high tensile costs this much. Okay. And then he said, oh, this one is foreign. The amount is maybe 50 Ghana per rod. Okay. And this is local. Okay. It's about 25. Immediately, because they want to cut cost, they say, oh, then let me go for, but they are all 60 mm, right? They say yes, then they go for that one. The moment you flip from high tensile reinforcement to mild steel, there's a huge gap in terms of strength. In fact, the high tensile has about 410 minimum, 410 Newton per meter square as the strength. The mild steel is 250 Newton per meter square. So if in my design I use 12 mm high tensile, and you get to the ground and you use mild steel 12 mm, you have reduced the strength by half.
Okay. But before you continue, to those of us out there who don't understand reinforcement, high tensile, mild, can you break it down a bit for us? When you say reinforcement, what is reinforcement?
So reinforcement in concrete is actually the iron rods that you use.
The iron rods.
Yes. Okay. So reinforcement now with modern or new, like with the innovation in building technology, there are so many ways of reinforcing a concrete, but the commonest one we have around is the iron rods. Okay, so either you use this steel element or you use ordinary iron rods. Okay. So, and then based on how they are formed, one tends to be high in strength, so we call that high tensile or high yield. And then we also have the mild steel. So now in the drawing, you have to be very particular in choosing the right one according to the drawing, because you see, nobody decides the strength of the concrete apart from the civil engineer or the structural engineer who designed the thing. So I can say, okay, my concrete should be of strength maybe 25 Newton per meter square. I decide, or you can say class C25 or C30 or C40 or any strength that you are. But those ones, during the course of the design of the structure, the structural engineer uses certain parameters, and so those parameters tends to be the specification that the structural engineer gives out after, in addition to the drawings. So when you go contrary to that, you have actually compromised the stability of the building. No, now it's not only even those the individual materials, but also, you see, when you have a structural engineer or a civil engineer on the project, that civil engineer is responsible for advising the client also in choosing your materials. Look, even ordinary sand that you use on site, or even water that you use, the water should be potable, it should be drinkable. If you can't drink it, you shouldn't use it for construction. These are all rules and things that...
And they know this.
Yeah, I don't expect the clients to know, but the engineer knows. So the engineer is the one, or the architect is the one who's supposed to advise the client on that.
Right,
do you get it? Yeah. The reason why the water that you use for construction should be fit for drinking is because if it's not fit for drinking, it means it may contain some chemical constituents that can react with the cement. You get it? And affect the entire structure. The entire strength of the concrete. So it's very, very important. Look, even the iron rods, we think when it is drawn, I can just call a steel bender and then put some iron rods in there and it's done. If it's done, it ought to be supervised and monitored and evaluated by an engineer. So usually on government projects or good construction projects, every structural element before the concrete is cast, the structural engineer ought to come, inspect, and see that what he has designed is what is being done, and then sign that one out. Do you get it? Before then, because when you cast the concrete and you ask the engineer, come and check the integrity of the concrete for me, everything is covered. So he's just coming to test the strength of the concrete and then probably maybe guess the reinforcement in the base on the drawing. It may not be so, and then that creates a problem.
Yeah, and also, so about that, so how do you structural engineers, test for the structural stability, assuming the building has already been put up?
Okay.
Do you just look at it and you can say, hey, this building can stand? Or there's a way you go about your checking,
Okay, so in checking the structural integrity of a building,
Yeah.
there are several ways, there are several methods that one can use, okay? And usually, when the building is built, it's already constructed, a lot of the details are covered.
Exactly.
And so there's a process that, civil engineers, construction engineers, you are trained to follow.
Okay.
Now, the right way to go about it is to check, maybe the first thing you do, take the drawings from the client, okay? So when I have the drawings, I have an idea of what was used for the construction, and I'm just assuming that it was done according to what I have there. If the plan you have given me is different from what is there, I can't know. Do you get it? Yeah. For example, if there are areas to be lapped and you lapped at the wrong places, I wouldn't know when the concrete is cast. I wouldn't know. So now, when I receive your drawings, the next thing I'll do is also to test the various strengths of the structural element. So maybe your column, I will come test the strengths of the columns. There are several non-destructive means by which you can use to get to test the strength of concrete. So for example, I can use the rebound hammer, or what we call the Smith hammer. Okay. That's the commonest one. It's just like a small cone, like you hit at it and then you press and then it strikes, like there's a rebound hammer in it, and then it hits it and then gives you a recording which will tell you, the average will tell you the strength of that concrete for the column. So I'll do that for all the structural elements. And then when I finish, I'll come back and then model the building that you have given me. Also, just not to miss this one out. Yeah. The foundation too, I also have to dig around the foundation. So they'll dig around the foundation and check the size of the foundation and then compare that with what you have in the drawing. Now, when all this information, when all these things are done, when you have projecting reinforcement, you can cut some and then test the strength of that.
Interesting. So without the particular device, are there signs or are there ways to look at a building to tell that this building is not structurally stable? Okay. The integrity might be affected. Are there ways to tell? Are there some signs we can use to tell? Assuming I'm not a structural engineer, or the client is not a structural engineer, can I see my building and say that no, there's something wrong with this building? Are there some signs?
Okay, so apart from obvious or visible, the most visible signs that will cause a scare or give a clue to somebody that the building is not stable, largely cracks. Okay, but you see, there is some minimum amount of crack that is accepted. But let me explain this.
Yes, please do, because we need to understand this.
Let me explain this. You see, there are cracks due to shrinkages.
Okay.
So maybe I cast a concrete. Shrinkage. So like I have a wet concrete.
Yeah.
The concrete is exposed to the weather during the casting. After casting the concrete, I have to cure the concrete. Curing the concrete means you are keeping the newly laid concrete under a uniform condition of low temperature during the hydration of the cement compound. Okay, so when the cement is hardening, okay, it emits heat. We call that hydration. So during the hydration of the cement compounds, you need to keep the concrete under a uniform condition of low temperature. That is why you see when they cast concrete, maybe a day after, you see them pouring water on it, or putting some sand and spraying water on it, or covering it with damp sack. These are all reasons to keep your concrete under a very uniform condition, so when these things are not done, you can see that the concrete during the course, after setting, during the course of hardening, it shrinks.
Oh, that's when the shrinking happens. Okay.
So now, as it shrinks, you see, like, they'll be bonding to one another, and then it will end up causing some hair cracks on the top.
Cracks.
Those ones are not serious cracks.
Okay.
Do you get it? Those ones are not serious. Just that they are conduits for the passage of for the passage of moisture or water, do you get it? Into the reinforcement later. But usually when it's on top of the concrete, it will be screeded or the finishes will be applied. So now back to your question about visible signs of a structural failure. These ones, they are technical, and when you engage a civil engineer, a professional civil engineer, he will do some testing, okay, and then after the testing, he will get the primary data. Then he will model or simulate the primary data, put the whole building onto, let's say, a form of apply the required loads. Do you get it? And then when that one is done, he will see whether, the output of the analysis will be a working drawing. Then he will compare that with what you have and see whether your building was designed right or not. So these are all things that can help one to know if the building is stable.
After we've noticed these problems, what do we do to curb it? So assuming we've seen the signs, we've noticed the structure might fall, the structure is unstable.
Yeah.
What can we do?
There are several options available to the civil engineer. There are several options available to the civil engineer. Some of which are retrofitting. Yeah. Okay, so retrofitting is where you see that probably based on the span of the beam, you may have to introduce some, columns at certain areas. Yeah. But the building has already been built. Yeah. Or maybe some areas need to be shored with some additional structural elements or like structural members. Then you introduce that more like an afterthought. So we call that retrofitting. Okay. So a column section may be small. You may weave a reinforcement around it, get channel that into the foundation and then cast around it. Yeah. Or you can introduce walls, shear walls, or you can introduce additional like structural elements to make sure the building is done. You see, but there is also, aside all these things, there are also now modern tools that the engineer can also attach to some of the structural elements and get to know what is inside.
And before I forget, you mentioned something on materiality.
Yes.
Materials.
Yes.
So how does materials affect structural failure?
Okay, so the quality of material is important. Okay. Earlier on, I spoke about the sand and the cement being used.
So in terms of materials, do you mean the external finishes?
No.
So what do you mean?
Okay, so now, if you're talking about structural stability or structural integrity or like the strength of a building, the finishes are all external items that are like additions. They are like accessories on the building. They don't contribute to the strength. No. Okay. But the strength of the building depends on the structural systems, the structural elements that are in the building and how they are all connected or linked together. Okay. Look, if the structural engineer designs the building and then the client, by virtue of saying, oh no, the building is for me, look, take this wall out, take this column out, or remove this. In fact, I've had several encounters like that.
Yes.
There's some examples where after I designed the building, I got to the ground and the client on his own volition has taken some of the beams out of the building.
Wow. Yeah. No, but I mean, if it's my money and I don't want it there.
Yeah, but you don't have the right to say you don't want it there. You can say that at the beginning. Okay. Do you get it? Okay. Then like, let's say you agree on a certain size. The architect has given you the size of the rooms, of your various rooms. Yeah. Maybe your hall, you know how big the hall is. Yeah. If you want to increase the size of the hall, go back to the architect and tell the architect, I think my hall is too small. Do you get it? I want a bigger hall. What can you do? The architect does not just design the individual buildings, but he designs the buildings so that they will all function together. Yeah. So when you tell the architect will know how to expand it. When the architect remodel the entire room, he will consult the engineer. How is this thing going to work? Yeah.
Then so by the time it reaches to the structural engineer, that's already been done.
Exactly. Okay. Then he will now make sure what has been designed stands. Okay. That is the work of the structural engineer. Wow. But so now when the client on his own stands there and then says, oh, the building is mine, so take this column out. Take this beam out. I don't want this.
I think they feel they are the ones paying the money and it's coming from their pocket. So they have a say and decide what they want.
Yeah. They have a say, but the say should be channeled through the professionals. Because now the building is yours,
Yeah.
but you've engaged
professional.
a professional. You've engaged a structural engineer.
Yeah.
The structural engineer has appended his stamp on your drawing. He's partly liable. So now, if he's partly liable, then it is also incumbent on you that if you want to make some changes to it, don't change that. The moment you change it, you kind of remove the liability from him to you.
Exactly.
Do you get it? Because if the building should fail, if the structural elements should fail, of course, the engineer will not just be hauled and then maybe the license taken away, but the building will be investigated. What happened? What materials were used? What are the sections? Was it supposed, like those structural elements that we have seen? Was it going to contribute to having the structural stability of the thing? All these things will be investigated, and then we will see if it's from the engineer or it's from somebody else. Okay. And most of the time, when the building is designed by the architect and the drawings are given to the clients, they take it for permits, then they choose their own building team.
Yeah.
They don't call the architect again, they don't call the structural engineer again, they call some masons, get some workers.
So these are also major causes that lead to the structural failing.
Exactly.
Okay.
Because you see, if I, the civil engineer, designed your building and I use a certain class of concrete, I know the batch, okay? I know the mix that will help me achieve that.
Suitable for
exactly, for me to achieve the strength that I use in my design. So I will advise you, when I get to the ground, like if let's say an ordinary person gets to the retail shop to buy reinforcement, you say, oh, I want to buy 5/8 or I want to buy half inch. Half inch, they can sell 12, in fact, half inch is 12 mm. They can sell 11.5 now on the market as 12. The moment, instead of 12, if you use 11.5, if you use 11 mm, you have compromised the strength of the reinforcement.
Very, very, very insightful.
Yeah.
Very insightful. We are grateful. So, what are your final words to our online viewers?
Okay.
One final advice. Can you tell them something?
Okay.
Regarding...
Okay. So, maybe I'll put it this way. My advice to builders or to clients is that engage the services of professionals. The right professionals, qualified professionals to do your job for you. Because you see, the earthquake that occurred in Turkey and Syria, it took only 45 seconds. And within that 45 seconds, children became orphans. Homeowners became homeless people.
Yeah.
You see, women who have wonderful families became widows. So you don't have to take, the integrity of your structure something lightly. Yeah, so you have to take it serious, engage the right professionals, get the right, in fact, they will advise you on the way forward because they are your eye. And then they will speak to your ears and show you and direct you. You are paying them for those advice. And so engage the right professionals and then take the advice they give you.
Okay.
Yeah.
That's fine. Thank you. Thank you very much, Engineer Cudjoe.
Yes.
Thank you very much. Thank you very much.
Thank you too for having me.
Once again, a very big thank you to our sponsor, Ahimfie Estate. They provide sustainable and top-notch homes. Do make sure you stay in touch. And you out there, do make sure you join us next time for more insightful discussions on the Housing and Construction channel. Go like our page, share, and subscribe. You'll find a link in the video description below. Do not forget to share our page, like, and subscribe. I'm your host, Bash. Stay tuned and connected for next time.